In a time of rising temperatures and climate instability, most of the attention goes to greenhouse gases. But there is another way, often overlooked, to stabilize the climate and cool the planet: plants. Unlike high-tech geoengineering schemes, forests, wetlands, grasslands, and marine ecosystems bring numerous benefits beyond just cooling the atmosphere. They increase biodiversity, they can prevent floods, and prevent erosion. But for now, let's talk about how they stabilize the weather and promote cooling. We all know that plants drink water through their roots, but what happens to that water? Most of it comes out through the leaves as part of the process of photosynthesis. In fact, for each molecule of carbon dioxide fixed and each molecule of oxygen released, several hundred molecules of water are evaporated. This is what we call transpiration. And it cools the forest in the same way sweat cools the body, the evaporation absorbing the heat. That's why forests feel so cool. It isn't just the shade. On the edge of the Amazon rainforest, temperatures are consistently 5 degrees cooler than on farms just a short walk away. And in Sumatra, native forests have been measured to be 10 degrees cooler than neighboring palm plantations. Leaves aren't just leaves. They're home to many species of bacteria, some of which are light enough to rise high up into the atmosphere along with the transpired water vapor. These bacteria are small, but much larger than the water vapor particles. So the gaseous water vapor uses the surface of the bacteria to condense into liquid droplets, creating clouds much more quickly. Forests, grasslands, and marine ecosystems each produce their own kind of condensation nuclei as well. In this way, plants seed clouds. When the water condenses at cloud level, it releases the heat that it absorbed during evaporation. Therefore, transpiration moves heat from the ground level, where it would have been trapped by greenhouse gases, up to high altitudes, where a lot of it, as much as half according to some experts, radiates back into space. Heat exits the Earth, and the Earth cools down. Now what if for some reason we didn't have the plants here? Well, then we wouldn't have the condensation nuclei, so the water vapor wouldn't be able to form clouds, and would form a haze instead. Then it causes heating, not cooling, because uncondensed water vapor is itself a greenhouse gas. So we know from the previous 2 points that more plants means more clouds because of the transpiration and the condensation nuclei. While clouds have all kinds of warming and cooling effects depending on various conditions, on average we get a net cooling effect. Overall, more clouds means a cooler atmosphere because clouds reflect sunlight. Another important feature of clouds is that they make rain. The worst damage from climate change comes not from heat per se, but from floods, droughts, fires, and irregular rainfall. Intact ecosystems help extend the rainy season by absorbing water into the soil, which replenish aquifers and feed springs, which then feed water to plants to keep them green and transpiring. This makes them way more resilient to fire. Healthy soils and wetlands are also like a sponge that mitigates flooding during the rainy season. You know how carbon is a pretty major greenhouse gas? Well, plants are made mostly of carbon. Not only does their growth directly take carbon out of the atmosphere, but lots of it goes underground, taking the form of their roots as well as carbon-containing compounds the roots exude. This carbon that was once in the atmosphere stays underground, sometimes for hundreds of years if left undisturbed. Grasslands and wetlands are especially good at sequestering carbon and building soil. Finally, let's not forget the 2/3 of the planet covered by water. The ocean food web is, like the terrestrial, based on plants: seaweed, algae, and cyanobacteria. Okay, that one's not technically a plant, but let's just include it. Marine ecosystems contribute to cloud formation, as do land-based ones, and they also sequester massive amounts of carbon in the form of shells, which are made of calcium carbonate. When reefs, estuaries, and kelp forests are healthy, shellfish thrive, and their shells take carbon out of the atmosphere, while also counteracting ocean acidification. Okay, great, let's just plant trees anywhere and everywhere and fix climate change right now. What are we waiting for? Well, be careful. There have been a number of reforestation efforts, and some have ended in disaster. For example, when fast-growing trees suck up the available water and die, leaving the land a desert. That kind of thing often happens when we use carbon calculations to guide ecosystem regeneration. We have to think holistically. A healthy forest is more than a bunch of trees. A palm oil plantation has a lot of trees, but it doesn't make clouds, cool the air, build soil, or prevent drought like a forest does. Not just forests, but all ecosystems are like organs of a living planet. Like your organs, they control the body temperature, direct its fluids, and maintain the life of the whole.